I'm very quickly just going to show you this because I just want to show you that there are other tests out there. So this is the Balsam agility test, or change of direction test, proposed to be a better kind of measure than what you saw with the zigzag test, meant to replicate soccer match play. But there is no actual evidence of repeatability. And this is quite interesting because, you know, this is back to 1994, and I can't find any evidence which has really shown that it's repeatable. Yet you actually see this being used, not just in the literature, but you see S&C coaches in soccer using this as their test. Again, it's very much the same principle as all the others, that what we have got here is we've got spatial certainty, we've got temporal uncertainty. So what you can see is the athlete, again, is going to sprint. They're going to sprint from A to B, then they're going to sprint from B to C. So they sprint 7.5 metres, then they're going to turn at B, and they're going to sprint back 7.5 metres, they're going to turn through C, they're going to turn through, from C, they're going to run through D, which is another 7.5 metres, then they're going to turn through E, and then the test is in essence completed. So there are a number of changes of direction. So in many ways, if you look at the pattern here, it's a bit like a zigzag test, isn't it? A to B, there's your first 7.5, zigzag was 9-ish. Then B to C, so you've got the first zig. Then we've got another 7.5 metres. Then we turn from D to E and zag. So in other words, you've got that kind of zigzag approach. So it doesn't feel very different to the zigzag test that it's meant to be replacing. But you still can't separate out what is in essence a turn to the left, a turn to the right. There's still quite large distances being sprinted. So all the inherent problems that we referred to with the zigzag test, that we referred to with the Illinois test, are absolutely at play here. So don't be fooled into thinking, oh, it's a soccer specific test. Is it? Does that really replicate what happens in a game of football? And then we've got the L test from Weber and Lander. Notice actually a lot of these tests are actually pretty old, and the principles, you know, the modus operandi of these tests hasn't really changed. I think what has changed more recently is our recognition about their suitability in terms of validity and reliability. So it was originally proposed to be used in rugby union. It's actually being used for league as well. 3 trials, that makes sense because they're looking at kind of getting reliable results, and they've got good reliability. So they've got an interclass correlation of 0.95, so its test retest was good, and their technical error of measurement, so again another approach for assessing reliability is technical error of measurement, was 2.8%. So the smaller that percentage, the more repeatable the test is. So again, showing good reliability. Same thing here though, it's correlated to sprint speed. So is that a bad thing, as we clearly have shown it is with, for example, Balsam test and the Illinois? Or is it potentially an okay thing, as we saw with our 505 agility test? So, same thing, we know we've got spatial certainty, we've got temporal uncertainty. But here we go. What you can see is that they're going to sprint 5 metres, they're going to turn around the first cone, sprint 5 metres, turn around the second cone, sprint 5 metres, turn around the third, and back. So there is 20 metres of sprinting. Although there are accelerations and decelerations, there are 20 metres of sprinting. So is this really assessing agility? It's, a change of direction. It's assessing repeated changes of direction. But what you're not getting a handle on is how good is the athlete's change of direction. If you want to get it, you probably just want to do the single turn, in this case, to the left. So where you've got cone 1, that single turn around the cone and sprint 5 metres, that was your change of direction, and then you repeat it to the right. In essence, what you're measuring is repeated abilities to change direction. So again, it falls into that same trap that we saw with the zigzag test and the Balsam test. It doesn't seem to be as bad in terms of its validity as the Illinois test is, but it's certainly still got issues of validity. So it really does offer some food for thought, I suppose, in terms of, well, you know, it's got good reliability. Yeah, it has. So test retest is good, but that's not important if we can't have a test that is valid in terms of both assessing the suitability in relation to sport, and again, the same thing applies. Does that really replicate what happens in a sport? and also in terms of the validity as a measure of change of direction. There are too many changes of direction to understand what their ability is. And then a fairly recent one, which is Paul and colleagues, which is from 2000, which is a t-test. And in fact, t-tests have been used for a while, but I'll just refer to this one because it's quite a nice example. It's got 4 changes of direction, so that automatically should perhaps set off alarm bells for us. But it correlates only reasonably well with sprint speed. But then you have to ask yourself about kind of what are the cues of the test. It has been modified for certain sports. So there is a hockey version, there is a rugby version, there's a soccer version, all of which in essence have just modified the distances between cones, as you're about to see. And again, it falls into the same thing. We clearly know this is a planned test of agility, it's a change of direction. We clearly, as you can see here, we've got spatial certainty, we've got temporal uncertainty. And here what you can see is that you sprint in initial, it's 9.14 meters. Why is it 9.14 meters? Well, it was originally in yards and feet. We then run cone B, we sprint then 4.57 meters. We turn around cone C, we run across to cone D, we run back to B and back to A. So same thing applies. It's exactly the same issues that we've seen with our zigzag test, that we've seen with our L test, and to a degree what we saw with the Illinois test. Here, we're going to call it, let's call it 9 meters, that's 9 meters. And then if we've got from B to C, that's 4.5 meters, so that is what, 13.5. We sprint from C to D, that's another 9 meters, so now we're at 22.5 meters. And then we sprint back, which is another 9 meters, so we're actually sprinting nearly 30 meters. So sprint speed must play a part. You can't separate out their ability to turn to the left, although they are turning to the left because they're turning from B to C, and they're turning from D to B, but the turn from B to C is very different from the turn from D to B. It's a right angle turn that you're making from B to C. In terms of D to B, it is basically a linear motion. It's a bit like we saw with the 505 test. You're running into the line, you're accelerating back out the line. You've then got the turn from B back to A, which is a right angle turn, but by that point you've already accrued quite a bit of fatigue from doing all the other turns. So the test seems very, very flawed. It doesn't seem to take into account the kind of the accrued fatigue. It clearly has got more than one change of direction which you can't separate out. And clearly sprint speed, despite what the authors are telling you, you can see how sprint speed would play an important role in this test. So one has to question both the validity and reliability of this. Now, what they have shown actually is that their t-test across trials, they've got trial 1 0.94, trial 2 0.97 and trial 3 0.98. So this is interclass correlations. So they've got good repeatability within their test. They've then correlated it to other variables. Well, now that's almost irrelevant. The correlation, the R, which is the kind of the variable of interest, is actually being misinterpreted here. They've given us a correlational R, which is actually R is not the same. This is R squared. So this is kind of how much variability there is in the test. So they're actually saying there's low variability. So actually 0.04, 0.97, 0.98 isn't correlated trial 1 to trial 2 or trial 2 to trial 3. It's how much variability that there is in the test. So there's low variability. They're saying there's actually low variability for all their tests. And in fact, in the vertical jump, very, very, very good in terms of test retest. Sorry, within the data, it's very, very good scores. But you can't get a sense of whether the test is actually correlated. And actually, if it's correlated to a vertical jump or a 40-yard dash, it's not that important. What's important is the test-retest reliability as a measure. And we haven't really got to grips with that in this data set. If we look at this data here, which is This is a modified agility t-test, so it's slightly different. But what we've got here is limits of agreement data sets. I referred to limits of agreement in previous sessions, but also within this set. And what you've got is limits of agreement plots for women on the left and men on the right. So what you can see is the middle line refers to the bias score, and actually fascinating, both for the men and the women, they've got the same bias score. So this is a 0.03 second, that's the mean of the differences, is 0.03 seconds across those tests for this population group. But notice that there is a large spread of the data. So what you can see in the women, the data spreads from 0.03 to minus 0.3 to plus 0.3. So you've actually got a spread of data there of 0.66 seconds over a mean difference of 0.03 seconds. So there's a large degree of variability. And if we look at the males, in the males 0.03, but we go from negative 0.34 to positive 0.40, so we've got a spread here of 0.74 seconds, nearly 3/4 of a second variability across two tests. So this is telling us that the reliability is not good. So not only is the test not valid in terms of the discussion we've just had, but it certainly doesn't also seem to conform to the notion of reliability given how spread the data is. Fundamentally, what you're looking for is a low bias score, which we've got, that's the mean of the differences, but the data for the group should be closely aligned to that bias score. The further those confidence intervals are apart and the data within them, the less reliable the data is.